Interpreting with functions. Any function can be written as a table, graph, verbal model, or equation. If it's a linear function, we can find the rate of change and the y-intercept from any of these representations. Remember, to find the slope, we can use the formula for slope, which is if you're given 2 points with the ordered pairs of x1, y1, and x2, y2, the slope formula would be y2 minus y1 over x2 minus x1. And to find the y-intercept, or sometimes referred to as the initial value, we look to where x equals 0. So if we look at a given table, here our function is in table form, we can use any two values to determine the slope. And then we can find where x equals 0 to determine the y-intercept. So our slope, we can use any two values from the table. So let's, in this example, we're using the value of 1, 4, and 2, 7. So 1, 4 would be the values of x1 and y1, and 2, 7 would be the values of x2 and y2. So y2 minus y1 is 7 minus 4, which is 3. And x2 minus x1 is 2 minus 1, which is 1. So 3 over 1 gives us a slope of 3. And since x equals 0, we see that right here, that's going to give us the y-intercept. So if when x equals 0, we have in the y row 1, then the y-intercept would be equal to 1, since when x equals 0, y equals 1. Now, sometimes the table will not show the x-coordinate of 0, so you won't be able to automatically be able to identify the y-intercept. In that case, you need to figure it out. And there's a few ways to do this. There's actually 2 ways to find the y-intercept for this example here. We have the function y equals 3x minus 4, and the table that is representing that function. The first method is we can simply continue the table so that we can find y when x equals 0. So we can see that the y's are moving at intervals of plus 3. So in order to work backwards to where x equals 0, we need to subtract 3 from y, because we're moving backwards from that last x value of 1 to 0. So if we move backwards, we're subtracting 3 from -1 to get -4. So when x equals 0, y equals -4. And this technique really works best when the table is close to x equals 0, right? The first value was x equals 1, which is just 1 unit away from 0. So it was really easy to count very fast backwards just 1 unit in the table to see that value for x equals 0. Another technique would be to substitute for x as x equals 0 and solve for y using the given equation. So if our equation was y equals 3x minus 4, we're substituting in that x equals 0. So that would be 3 times 0 minus 4, and then 0 minus 4 gives us the y-intercept of -4. It confirms what we found when working backwards from the table. And note, this technique only works if you have the equation. You can't substitute x equals 0 into an equation if you don't have the equation. But either way, given a linear function, we can find the y-intercept by looking for that value where x equals 0, and we can find the slope by using 2 ordered pairs in the function.